started off discussing about the data types, or we have started off discussing about statistical analysis. As part of this, we have discussed about the various data types. As part of this, we have discussed about continuous data and discrete data. We have also discussed about 4 other data types, which is nominal, ordinal, interval, and ratio. If we can represent data in decimal format, then it's called as continuous data. If you cannot represent something in decimal format, so if decimal format representation not possible, then we call it as discrete data. This is a primary difference between continuous data and discrete data. Then what is nominal data? If you just have names of something, for example, if I give you names of colors, right, some labels, example colors such as maybe red color, green color, orange color, etc. I cannot reap a lot of information from this kind of data. And then we have ordinal data. For example, if you're looking at order of the data, such as customer satisfaction. Customer satisfaction rating. Here you'll have satisfied, neutral, unsatisfied. Yep. Then it will become ordinal scale. Interval scale is if you do not have a zero value, right? If you do not have an absolute scale, that is when we use this. For example, it could be temperature, or it could be a rating scale on say 1 to 10. Two people rating 7 does not mean that's the same value which is given by two people, right? Someone might be more lenient in providing a rating of 7, someone might be more stringent, but still he might provide a 7. Two people giving 7 does not mean they have equal preferences. Ratio has an absolute scale. And here, if you speak about the price in dollars would have an absolute scale. If you and I, both of us, pay $10 to purchase a product, it is as good as saying that we have spent the same amount, right? So these are the data types that we have discussed about. Then we have discussed about probability, the most important part, and we have discussed that the formula is number of interested events divided by total number of events. This would give us a probability. If you have probability on the x-axis, or if you have a random variable or the events on x-axis, and if you have probabilities on the y-axis, then it is called as probability distribution. If your random variable is continuous, it is called as continuous probability distribution. And if the random variable of interest is discrete, it is called as discrete probability distribution. And then we have discussed about a lot of variants of probability distributions, right? We have discussed about normal distribution. And the properties of normal distribution are that it will be symmetrical across the mean. Mean will be equal to median, which will be equal to mode. And it ranges from minus infinity to plus infinity. And we have some empirical calculations or values. One is if your data lies between plus minus 1 standard deviation or 1 sigma, you'll have roughly 65% or 68% of observations which fall within that range. And if the data falls in between plus minus 2 standard deviations, you'll have roughly 95% of the observations which meet customer requirements. If it's plus minus 3 sigma, then you'll have roughly 99.73% of observations which meet your customer requirements. Since each dataset will have a different mean and standard deviation, we thought of having a common way of representing that using something called as standard normal distribution. Even before that, what if data does not follow normal distribution? If data does not follow normal distribution, you'll have to normalize the data or standardize the data, right? How do you do that? You can transform the data and try to see whether the transformed data follows normal distribution or not. There are a lot of ways of transforming the data. You can do a log transformation or exponential transformation or reciprocal transformation or square root transformation or cube root transformation, and the list would go on and on. Or you can resort to Box-Cox transformation, which uses lambda values, and if you keep changing the lambda values, it would apply different transformations on the data. For example, lambda equal to 1, it might follow some transformation. Lambda equal to 0, it might do some transformation, so on and so forth. Or you can resort to Johnson transformation. It gives you a mathematical equation to transform the data and make it normal. Despite all these transformations, if the data still does not follow normal distribution, then we resort to techniques which are applicable for non-normal distributions, such as your Poisson distribution, so on and so forth. Standard normal distribution is also called a Z distribution, and the formula for Z is x minus mu divided by sigma. And when you apply standard normal distribution or Z distribution on the data, when you standardize the data or normalize the data, mean would be equal to 0 and standard deviation would be equal to 1.